Dave Balaji is the Vice President of IoT for T-Mobile. Previously, he ran the Corporate Strategy and Analysis Group at T-Mobile, where he championed the effort to develop a comprehensive new strategy for T-Mobile in the IoT market. Welcome to the stage, Balaji.
Thank you for having me here. I want to spend the next few minutes to talk about massive IoT and some of the innovations that T-Mobile as a company is bringing to market in this area. But before I get started on the topic, I want to spend a couple of minutes talking about T-Mobile as a company. We launched the UnCarrier revolution about 5 years back, because that's got a bearing on where we are going. As I mentioned before, we launched the UnCarrier revolution about 5 years back. At that time, the wireless industry was about restrictions, limitations, and figuring out a way to extract as much money from the customers as possible. We had a different point of view. We decided to zig when the whole industry was zagging. We decided to listen to our customers, to understand their pain points, and come up with specific moves that address those pain points. For example, when our customers told us that they did not want to be locked up in 2-year contracts, which was very common at that time, we launched something called Simple Choice, which was our very first UnCarrier move. And Simple Choice was about flexible, transparent pricing and the fact that we told the customers that they're no longer bound by service contracts to us. i.e., if you're a T-Mobile customer and you didn't like our service for some reason, which I don't know why you wouldn't, you're free to leave. No questions asked, no penalties. And then when our customers told us about the fact that they were paying exorbitant overage charges when they travel internationally, we came up with a move called Simple Global, which essentially removed data and text fees for over 255 countries worldwide. We followed that up with several moves over the next 5 years. And over that period of time, our subscriber base has more than doubled. We're slightly over 81 million customers at the end of Q1 this year. And the service revenue, or the total revenue, has also doubled over that period of time. And my favorite metric is the churn rate, which is a measure of how sticky our customers are to us. And that has more than halved. That means the customers are staying with us twice as long as they used to before we started this UnCarrier revolution. It's kind of interesting how a business can transform by just listening to your customers and offering what they want. Now, that's just one part of the equation. The other part of the equation is the network. We have invested billions and billions of dollars over the last 5 years in transforming our network. Every single year, we've added hundreds of thousands of square miles in coverage. And you're wondering, what does that look like? That's the network that was there 5 years back. And this animation will show you the network that is there right now. It is literally night and day in terms of where we've come in the network journey. And our network today covers about a little over 325 million POPs in the United States. And we're not stopping there. We're continuously investing on our network. We just spent about $8 billion a year or so back buying up more spectrum such that we can build a better network for both people and things, which I'll come to in a bit. And we've already deployed that spectrum. We've deployed that 600 megahertz spectrum that we bought in the auction in over 3,500 cities nationwide today. Now on to more interesting things, which is IoT. I'm going to take a moment to sort of establish the context in terms of what are the use cases possible in IoT. This is a chart from a study that Ericsson published a few months back, which categorizes IoT into 4 broad categories. The first category is massive IoT, which is what I'll be talking about today. And massive IoT deals with devices in huge volumes that transmits small amounts of data infrequently. Think about the sensors that are collecting pressure, temperature, and environmental conditions and transmitting them over the network. Or think about a utility meter that's measuring your utility consumption in the house. Now, these devices don't need to communicate that often, and even when they do communicate, they communicate in small volumes of data. But it's critical for those devices to exist to enable the vision of IoT. Because the vision of IoT rests on one fundamental thing, which is how do you create a digital representation of the physical world around us such that we can analyze the information, process the information, and act on that information. In order to do that, we need to deploy these sensors, not in the tens or hundreds of volume, but literally in the hundreds of millions or even billions of volume. That's the scale that we're talking about, and that is massive IoT. The next category is broadband IoT, which is sort of an extension of mobile broadband technology that exists today to enable use cases that require higher bandwidth and lower latency. Think about connected cars, think about drones, and even certain AR, VR type of applications. All those require a little bit more higher throughput than what is required in the first category of massive IoT. The third category pushes the envelope even further, critical IoT. And in critical IoT, we're talking about ultra reliability and ultra low latency. For example, a vehicle to infrastructure use case where a car is approaching an intersection that's turned red and is not stopping, and the system that's looking at it need to act on that information very quickly to stop the car. And in that case, even a few milliseconds of delay can make the difference between an accident happening at that intersection versus not. So that types of use cases that fall into that category is called critical IoT. And the last one is sort of the industrial IoT, which deals with connecting machines that exist in an industrial environment and driving more value by analyzing the data that comes about as a result of that connection. Now, obviously, all of these use cases require a solid network foundation to support it. And that's where technologies like Narrowband IoT, which we'll talk about in great detail today, 4G LTE, as well as 5G come into play. Going a bit deeper into massive IoT, now what are the challenges for massive IoT? All the challenges associated with massive IoT can lead to one question, which is how can we deploy and support billions and billions of devices at scale? When you think about that question, the first thing is cost. The cost of these devices need to come down, and it needs to be cheap enough for us to be able to scale to that level of scale that we're contemplating. And that's not just the device cost, that's the cost required to connect to the network, cost of servicing the device. All of that falls into that bucket. The second is battery life. Think about having to change battery across hundreds of millions of devices every week or even every month. That's not a very scalable solution. I certainly wouldn't want to do it, and neither would any of you. The battery life has to evolve from weeks or months to years for us to enable massive IoT. The third point is coverage. The reality is these devices are going to be everywhere. They're going to be out in the rural area sensing the environment. They're going to be down in your basement reading your utility readings. And the network and the coverage that support it has to go there. The coverage enhancements need to be there on the network to be able to reach those devices and communicate to those devices. And last but not least is the global reach. That's very important because us as carriers have specific geographies we operate in, but as a product company or an innovator that's leveraging the technology, you're thinking about global deployments. I build a solution and I need to be able to deploy it globally. So a technology that's based on global standards will allow for that seamless deployment across the globe, which is also critical for enabling massive IoT. The answer to it, from our perspective, it's Narrowband IoT. Narrowband IoT is a low-power wide area network technology that has been built on our existing mobile network. The unique thing about Narrowband IoT is it operates in what we call as guard bands, which is very similar to sort of the shoulder on the freeway. Or maybe even take the example of a road, right? The road is built for cars and automobiles. And in most cities, you have bike lanes. So bikes are far less sophisticated than cars and travel at a lot lower speeds than car. And the way of having a bike lane on the sides of the road allows for these two use cases to coexist. Take that analogy and put it on the spectrum context. We have the main swath of spectrum. It supports all the use cases, including your phones and tablets and all those other things that transmit vast quantities of data. And then on the side, you have these guard bands that are designed specifically to allow for those devices that don't need to communicate that frequently, or even when they communicate, it transmits very low volumes of data. So that's what Narrowband IoT enables, and that has a direct consequence in terms of how we optimize the communications to those devices, both from an efficiency perspective as well as, more importantly, from a cost perspective. So we launched a nationwide Narrowband IoT network last year, and it covers about 323 million POPs today, and by the end of the year, it'll be over 325 million POPs. And that's, I mean, when I think about that, I mean, it's pretty game-changing. I mean, you're looking at a technology that's designed for the future. It's designed to support use cases the next 10 years or 15 years down the road. And being at the forefront of that revolution is super exciting for me personally. Now, what are the key benefits of Narrowband IoT? First and foremost, better battery life. As I mentioned before, Narrowband IoT promises battery life of up to 10 years. Depending on the use cases, obviously. The more frequently you communicate, the more battery you use up. The second is the cheaper device cost. We have a $5 Narrowband IoT module, or several modules, certified on our network today, and that's probably the cheapest cellular module that you can find for advanced technologies. And that price is going to come down as things scale. The third is optimized data usage. This is another interesting aspect about Narrowband IoT, is it allows for a communication technology called non-IP data delivery, which essentially removes the IP headers, which are not that bad when you think about huge packets of communication, but as you shrink down the packets of communication, that can add up a lot of wasted data space. And by leveraging non-IP data delivery, we can drive about 30 to 40% savings in terms of the packet sizes that get communicated across the network. The fourth is obviously enhanced security. Narrowband IoT is based on GSMA standards. It transmits data across licensed spectrum and uses the same encryption technology that exists today in the cellular network, which is a SIM-based authentication and encryption. A combination of all those three provides a safe and secure channel for communications. Last is improved coverage. In addition to the standard deployment, Narrowband IoT also provides coverage enhancements mode that rely on repetitions of devices, data transmission, to provide an additional layer of enhanced coverage. And all of these things are relevant when you think about massive IoT and how we want to deploy and scale it. A quick summary in terms of how Narrowband IoT compares to some of the other low-power wide area access technology that exists out there. As you can see from the chart, the primary difference is the fact that we're using licensed spectrum and we're using industry standards. And that has effect in terms of scalability as well as security as you think about deploying use cases. Now to my favorite part, which is the use cases it can enable. Now, T-Mobile was the first carrier to launch a nationwide Narrowband IoT network. And we were the first so that the product innovators and developers could go ahead and solve for the last. The last time you have to drive around endlessly in a crowded city like Seattle looking for a parking spot. The last time you cannot find something that you've lost. The last time you have to worry about air quality because something is measuring and reporting and monitoring it for you. Or my favorite, the last time I don't have to set up 5 different hubs in my house to enable a simple automation in my house. I'm going to digress a little bit, because about a year and a half back, I was messing around with connected things in my home. I connected a bunch of lights and switches and so on and so forth. And it was the middle of the night one day, the power went out. And when the power came back on, for some reason, all of the lights were blazing at 100% intensity. I don't know why. There was probably a glitch which has since been fixed, hopefully. But more importantly, it was the middle of the night, so I didn't want to go and unplug all those devices. So I do what I do best, which is shout at Google and say, hey, Google, turn off my lights. And I get a polite response back saying, I'm sorry, I can't help you with that because I'm not connected to the Wi-Fi network. Well, sure enough, the Wi-Fi router was booting up. And once the Wi-Fi router boots up, it connects to the Google hub. And then it connects to all the hub it needs to talk to. And finally, the devices. 10 minutes later, I can finally tell Google to go turn off my lights. I was getting this close to losing my license to experiment in my house. That's not the future we want to imagine. The future we have is when those things don't have to go through those hops and hubs to reach the internet and be connected. It has to work a lot more seamlessly than that. And that's what I'm excited about, what a technology like Narrowband IoT can enable. I'm going to play a short video here that highlights some of the other use cases we're seeing on a network.
The Internet of Things is here and delivering real results, but the network requirements for each solution can be as diverse as the enterprises launching them. T-Mobile is driving IoT innovation with a multi-spectrum connectivity portfolio that enables a broad array of solutions, from the simplest sensors to the most data-intensive applications. To support the billions of IoT devices coming online, we're the first in the US to offer nationwide Narrowband, a network built just for IoT. A standards-based network, Narrowband provides a dedicated spectrum for low-bandwidth devices, allowing for highly efficient data transmissions. Whether it's parking meters in the city core or sensors deep in the field, Narrowband enables extremely efficient devices with battery life of up to a decade, and its signal goes deeper into buildings and even the ground. NB-IoT makes entirely new solutions possible and allows you to scale up faster thanks to long-term reliability and cost-effective data plans. For IoT applications that require efficiency but more features, like voice, T-Mobile's Cat 1 can help you deliver better products and experiences for your customers. For high-bandwidth IoT needs, T-Mobile covers millions of square miles with the fastest LTE network in the US. T-Mobile is also investing in delivering the coming wave of 5G IoT. Our network is uniquely positioned to realize the future of ultra-high-speed, low-latency connectivity that will allow us to remotely perform even the most sensitive tasks. With T-Mobile's multi-spectrum connectivity, you'll have a partner in innovation with a proven track record of putting customers first. We won't stop until the Internet of Things is working for you.
Well, as the video demonstrates, there's no one-size-fits-all, and we are bringing the technologies to market that allows for the spectrum of use cases deployed as it relates to IoT. And the other one is, as I mentioned before, we're bringing the same UnCarrier philosophy that has worked in our consumer world to this market by providing flexible, simple, and transparent pricing. Today, to access our Narrowband IoT network, you can get price plans for as low as $5 a year, and then we have a $5 module. That will drive the adoption of these devices down the road. And now my favorite part. I get asked this question a lot, which is, hey, what is the killer app or use case in IoT? And my answer to that question has always been, I don't know, right? And I'm not trying to be difficult, because I really don't know. Because it's not me that has the answer to that question of what is the killer app or use case in IoT. It's that 4% in a garage that's thinking about solving a specific problem that is going to come up with that next killer app or use case in IoT. Think about Uber and what they did and how they did it and how it transformed the transportation industry. So it's very important for us as technology providers to be able to get to that segment of developers and innovators that can experiment with our technologies and come up with the next innovative concept or idea. So as soon as we launched a Narrowband IoT network, we partnered with Twilio to bring a Narrowband IoT-focused developer kit to the market. And my colleague, Masood, will be talking a little bit more about it in his session tomorrow. And that's very important. It's very important for us to get that technology out in the hands of those developers and innovators so that they can start using that technology. And we also launched the nation's first NB-IoT hackathon in March. And it was a huge success. We had over 1,000 inquiries, about 25 teams participated, and came up with a lot of interesting ideas. I did not know that before the hackathon that 33% of the produce that gets shipped gets wasted. And there was a team that came up with an idea that could address that, leveraging Narrowband IoT as a technology. There was another team that came up with an innovative way to be able to sense the presence of a forest fires such that there can be enough adequate response to both the first responders as well as people living in that area. There was another team that leveraged Narrowband IoT to solve a problem associated with missing radioactive waste in the oil industry. I did not know that there was a problem, but apparently it is a big problem. And it's these types of innovations that we want to drive, leveraging our partnerships and into the community such that we can come up with the next killer app and use case leveraging Narrowband IoT together. Last but not the least, today we have several of our partners that are leveraging Narrowband IoT networks. We have a pool party today, and I encourage each and every one of you to come to the pool party and talk to these partners and understand the way in which they're leveraging the Narrowband IoT network to make a change in the way in which they're doing things today. Thank you for taking the time. It's been a pleasure.